Good morning, everybody. Last day. Welcome to routing working group meeting, Friday. Starting from today, we would like to experiment following way. We would like to hear your name and repeat it in a way we understood it. And if you disagree with our pronunciation, please repeat it one more time. We would really like your name to be clearly stated in Jabber and not. And just before you say your name, take a second and say it slowly so everybody can understand. Yes. And unless you show your badge to Martin, you cannot talk. Oh, sorry, Michael.
Oh, another experiment that we're trying in addition to the name repetition part is in previous sessions in this room, the door has slammed and been quite distracting. So we put a chair in the door. Hopefully there won't be much noise from out there to distract people, but it's kind of a compromise between outside noise versus door slamming noise.
We'll draft and document the solution.
Okay, so we'll get started today with AC talking about Yang keychain model.
Oh, I can see it.
Place, given that the camera's there.
Yes.
Probably about here.
Okay. Donald Trump, Grand Poobah of the Western Hemisphere. No, I'm AC Lindum, Cisco system. Anyway, I'm going to give you an update of the Yang keychain model. It's now a working group document.
So
okay.
probably either look there
Oh.
or hold this, because otherwise the sound cuts out and we look back.
Okay, I'll look there. It's now a working group document. If you remember, we had this discussion with the former members of the working group, the CARP working group, as to the relationship to the key table. And we came to the conclusion that the key table was something that was satisfied the same similar function, but it was a different deployment model. And this was, a deployment model that might be implemented in the future, and this was one that was implemented now, the keychain. So another thing I added is I added the clear text authentication. This was I got a request from the BFD design team, and they wanted this because many times with BFT, when you're authenticating the packet every, 5 to 10, 10 milliseconds, you can't do anything better than clear text. They really wanted this. And what I did is I also put in the security considerations. The clear text authentication should not be used unless there weren't any other alternatives. And the final one, this was the biggest change. We found out that we've been going on for 1.5 years with another IETF keychain. Now, this keychain was hidden in the syslog server model in netconf. But this keychain was akin to the keychain that's on your Mac, keychain utility. So we had a discussion offline. We decided to rename this to the routing keychain and the other keychain to the system keychain. I've had some, since that time I've said that I had the only true keychain and I shouldn't have done this. And I said, well, why don't you talk to these guys, and if you want me to change it, talk to the guys who have the sysmod, syslog keychain. I don't really see it as a big deal to have routing in the name because you use a prefix anyway once you import it. So I think it's my opinion is we've done this. If you have any strong opinions on this, send me email. We also think, as far as applied and operational state, we already have the operational derived state intermixed. We have very little derived state. We have it mixed in with the applied config. Now, if we go with a different model, we need to change it where we have applied config is supported implicitly by the model. So that could be a change. And we think it's a pretty rich set of functionality. One thing, we do have features in this module because we had a lot of different vendors. We had Cisco, Juniper, Ericsson, Wow, and Huawei. And we have a superset model with features to handle the things that not everybody supported. And we have some things that nobody supports yet, like we have the authentication that you'd need for TCP AO. And we also have, there's this standard, I don't remember which one it was, for doing for encrypting the keys in the model, and then you have to pass the key string encryption key using a side channel, of course, because you got to be able to share that somehow. So, but I think it's almost ready for working group last call. The only thing that I was thinking of adding, I see the ACL model has kind of a nice feature, but it's kind of hard to provide, and I want to talk to the other people, other vendors on this, is the ACL model has in the operational state a list of places where the ACL is applied, which can be useful. So I think I'd like to add that as well, similar to similar to ACL. You're going to want to know, if you're going to want to know where it's being used from an operational perspective. That's it.
Jeff, has one question that occurred to me due to some weirdness as usual that's happening in
Hey,
DFT.
excuse me, sorry, we're going to repeat the name just to be consistent. That was Jeff Haas.
Yes. C. I didn't see anything in the draft that suggests what you do when you have empty authentication. What do you think this should do? Is this the absence of the stuff in the container, or is there need to be an explicit cipher that is empty? You don't have to necessarily answer it. I was more curious whether this had been a point of discussion. I didn't see it, and I just want to make sure I didn't miss anything.
Actually, I did think of that. And this would be to roll from no authentication to using authentication and doing that gracefully. Nobody supports that today. And I think the application that's using the keychain would have to support that.
Well, the specific application in BFD is that we want to turn on authentication, basically zero cipher, to take advantage of the sequence numbering that is inside of there.
Oh, okay, that's easier to do. Okay.
So it's just basically a code point that says, hey, I support authentication, there's nothing here. So it's a bit of an unusual edge case. And
okay. Yeah, can you send an email?
I'll send, do you want it to you or the list?
Both, yeah.
Okay.
Thanks. Yeah.
So we have someone on the Meet Echo queue who I will add in, Chris Hobbs.
Hi, Chris Hobbs, Deutsche Telekom. So, AC, you mentioned the side channel cryptography thing. I'm wondering, did we get this from the security folks? Uh-oh.
I did get it from security folks. I said there was a possibility to. You're talking about which thing, the key encryption?
Yeah, I think you said that like you would pass an encrypted key and then use a side channel to pass the second half or whatever.
No, to share the key the key encrypting key.
Right. Yeah, no. So I was just curious if if that came from the security folks or if we talked to them about this stuff.
It depends on which security. It came from Brian Weiss.
Okay.
Who was CARP chair.
For the I'm imagining NetConf with SSH. It's not a very big deal, but perhaps with some other
Oh, right. Okay, you're thinking we don't need that. Okay, I could. Who would you think I should ask about?
Oh, no, I don't know. I was just curious.
Yeah.
Okay. Thanks.
It is a feature to use the key encrypting key, since nobody does it today. Okay.
I see. So besides address instruments from the list, do you feel there are any other unresolved points you need to work on?
Like I said, I think we're going to add this list that's in the ACL model that the working group last call. There's this list of places where the ACL is applied. I think we're going to do the same, and it's just an opaque string, but I think that would be useful too.
Okay, so we'll be waiting for an update from you.
Yes.
Does that create any like problems with updating later on when you want to apply this module somewhere else?
It's only operational state, so it shouldn't list the places it's applied. It does not. You have to import the model and apply it just like you do with a normal keychain today. You know, like a Juniper or Cisco keychain. You like use it to authenticate an interface, right, in ISIS or OSPF for authentication. So what this would do is, from the perspective of the keychain, you'd get strings that have these lists, a list of all the places the keychain is used. From an operational perspective, it's useful.
Okay, now, yeah, I understand better
Okay,
now. It's a
yes.
sort of back pointer method to figure out.
Yeah, and it's only operational state. It's not applying the keychain. I think the usage of the keychain remains with the applications that use it, not in the keychain module. Okay, I'm just going to go to the next presentation. As you know, Lotta and I have been working on the IETF routing model, which is a pretty central module. And we made a couple changes right before the IETF, and I'm going to go through those. Just talk about those. Now, one thing we do, I don't know how many of you, Lou's going to talk about this in the longer presentation. He's going to talk about schema mount. So one thing we did, we decided this model could satisfy a simple device as it was, or it could be, schema mount could be used to mount it inside a networking instance. And we know we didn't have to, the network instance is something Lou's going to talk about as well. I hope he shows up here. Is he in here? And that would satisfy the requirement for a BRF or virtual router or whatever. So we didn't need the routing instance anymore. So we removed the routing instance from the model. That was the biggest change. We still have, the model is still self-contained for simple, so it has a list of interfaces and a list of routing protocols. Now, one thing, we maybe don't need the separate list of interfaces, because in the device model that we're coming forward, we bind interfaces to a network instance or a logical network element. And again, Lou's going to talk more about that. Another thing we did, this was something since the beginning, I didn't really think in this central module that the router advertising protocol belonged there. I thought it should be in a separate, with all the other RFC 48, 46 protocols. So we didn't get rid of it, but what we did is we moved it into a separate module. So you have the base IETF routing module, then you have the address family specific ones, and then there's a fourth module. This was in the IPv6. This was bundled in the IPv6, so now it's a separate module. The reason it was there is because it is a requirement. I don't see Lotta. Is Lotta in here? It is a requirement. It is a requirement for IPv6. Router advertisement protocol. So Oh, yeah. Yeah, once we sort out this op state, there'll be some inevitable updates. As you know, right now it's split right at the top. We have the routing config and routing state, our top level trees. And maybe this will stay the same, maybe it won't. We'll see where we come out with the op state. It's, like I said, it's totally self-contained, which is good. You know, the question is, we have a list of routing protocols. Do we want to have in the networking instance a separate list of other protocols, or do we want to just use this list for all protocols? And I talked about the leaf list of interfaces. I think we can remove that now that we have the networking instance, if that model gets adopted. I just It's maximum stack fit seems to be a consistent theme here. Anyway.
So are you looking for a different next slide or not?
I am.
Okay, so we're going to.
I have just the last presentation is just one slide, I believe.
Oh, okay.
Go ahead, Shifan.
Okay. Shifeng Liu from Ericsson. So you mentioned that the operational state, it's not decided, but currently it's...
I'm going to be consistent about this. So could you repeat your name again? Sorry.
Shifeng Liu from Ericsson.
Shufeng Liu.
Mhm. The operational state structure, after we change this, it's not consistent with any of the existing models. It's not consistent with the current net node structure after the structure mounting, and also not consistent with the request from OpenConfig. So currently, the branch is in the middle. So I don't think it's on the top after the mounting. So do we have a preference what we want this look like eventually?
Yes, I have a preference, but my real preference is to get an agreement. That is above all. Right now, it doesn't make sense to start reordering something until we have an agreement as to how we're going to structure Yang models. So I think it makes sense to leave it as it is. The operational, I know you mean. Right now, it's at the top level. We have routing state and routing config.
Right.
Yeah, I agree. It probably will change. We'll see. But I'm not going to change it until Lada and I are not going to change it. He's actually done most of the work on this.
Right. Either
model.
split at the top or go to the bottom. But currently, the current structure does not make sense to me.
It probably will change. The one thing about that is, by virtue of that fact, everything that it has the protocol list, and the protocols, in the specific, you have the static routes, right?
Mm-hmm.
So by virtue of that fact, it makes all the protocols are supposed to have, be split right at the top with config and state. So
Okay.
I agree. This probably will change once we get an agreement, but we have none yet, so we're not changing it. Okay, there's not really nothing. One thing, when I talked to Lada, he wanted to keep this as really for a simple device IETF routing. So we have some very basic things in this augmentation to IETF routing. This is in a rib extension, and I think once we should have at least this much. So we for both IPv4 and IPv6 address families. And this draft hasn't changed. I know it doesn't have everything it's kind of, this is like a basic, or a fairly full function enterprise router. It doesn't have everything that under the sun. It doesn't have any MPLS stuff in it or any tunnels. So, and it hasn't changed.
Yours or mine? I2RS? Okay. So, how does this?
So I'm going to ask you to say your name, and then I'm
Oh,
going to repeat it.
Thank you, Dave. Thank you. Sue Harris.
So that
Huawei.
was Sue Harris. We're trying an experiment where we actually repeat people's names. So if I said
Sue
Sue Harris
Harris.
correctly, good.
Huawei. I'll say it slower, and that was part of my suggestion. So thank you, Dave. I'm sorry. You see, I know we've talked about this before, but how are you are you keeping this independent from the ephemeral I2S rib? Are you thinking of linking it in, and what are you thinking as far as the combination? I understand the config and the rib and stuff, and I understand why you say we're going to change it when we change it, and I'm all good with that. Just wonder, you're progressing toward the I2S model.
I think for the rib, there are more things. I don't think we'll ever put filter ribs or all the stuff
No.
that's in there. Never. So
Excuse me. I'll be clear. Sue Harris speaking again. What I'm specifically interested in is the I2RS rib, not the filter rib. That I'll present in a moment on how to deal with that.
Right.
What do you think? What do you want to do with the two of those? Are we progressing to where we're simpatico and we should try to align, or are we going to live in equal but separate silos?
Given everything else we're trying to align with, I would prefer the latter.
Okay, thank you. I mean, no,
Yes.
both are fine with me.
Okay.
Jeff Haas?
Yes.
Jeff Haas.
Let the record state, Jeff Haas will speak.
Okay, so what I say 3 times is true. Let's piggyback on part of what Sue's saying to begin with. So the I2S rib stuff does have some much more complicated configuration than you're trying to enable out of the box here, and that's fine. One of the things that we'll probably end up having to reconcile there once we get the ephemeral mechanism through netconf, because it's going to be useful for things other than just I2RS, it's probably going to apply here as well. And thankfully, the schema mount stuff actually makes this stuff a lot easier. So that's just something to think about, and maybe you can just take a look at, from the perspective of Rtgwg rather than I2RS. The second thing is more about the sort of common extensions that you're looking to apply. When we look at these things, you're right, these are common, they tend to be applied across lots of routers. Where this becomes a little interesting is when we start deciding that these are rib components that are going to have to be augmented by the operational state of various routing protocols. So we give the example in one of the earlier versions of the document I haven't looked at recently of here's what a BGP augmentation on top of the base rib model would look like. As we start doing this type of thing, what you've actually done is put into a separate document a common overlapping subset of what's going to be in other protocols. Have you thought about what this does versus the subsets that have to be provided by, for example, probably for a better example against these attributes, like say OSPF?
Well, we have thought about that, and I don't know, I think maybe when we get closer, I would prefer these to go into IETF route into the base, because I think these things are pretty much standard.
Mm-hmm.
But Lott and I don't agree on right now on updating it. So, and if one thing you could do from an I2RS perspective is say what subset of the I2RS function you think should go in the base rib in a document or at least in a email, a document would be okay as well. That'd be good. But we don't agree completely with the tunnel configuration and everything. And that's, that it automatically should go in here. But we pulled stuff out of here actually too, because we said, okay, we put labels in here, we need them. I mean, but that's not part of the base rib. That's something.
Yeah, and augmentations make sense for the most part, but
Yes.
so if your goal really is for these common components, I would suggest as a your modeling exercise to say, what hoops do people end up jumping through to implement protocol operational state on top of this?
Yes.
Pick OSPF because you have at least half of these are direct overlaps, and you have to decide what the overlap here versus the overlap in OSPF means. And if, for example, wide metrics is not the same as regular metrics for, like, say, ISIS, that's in this model, what do you end up doing in terms of name collisions, that sort of thing?
We don't use for the local rib, it's just operational state in OSPF, and I'm not off of the OSPF Yang model, but I'm on the design team. So there is no direct intersect with the protocol local ribs.
Okay, I'm gonna have to cut in here for a moment. We're on a much tighter schedule today
sorry.
than we were yesterday. So I'm gonna cut the line at Lou, let him ask his question. No, and Sue, that means you're not, because Lou was there before you. And you're up next, actually, Sue, so go ahead, Lou.
Okay, I missed the protocol, so I'm supposed to say Lou Burger, Lou Burger, Lou Burger?
Now you say Lou Burger, then I say, so.
Okay,
do it.
Lou Burger.
Lou Burger.
Awesome, thank you.
You can buy the Lou Burger down the street.
So AC, I want to pick up on a comment you just made where you and Lana don't agree on something, so you're not going to do it. I'll just want to point out that you're talking about a working group document.
Yes.
And I admit to being behind on mail, so if you've already done this, I apologize. But if the authors disagree, it's not for you to decide. And
Okay.
authors of a working group document, it's not for you to decide. It's for the working group to decide. So please bring the issue to the list, have the group talk about it, and then maybe the consensus will be to follow what you're saying, even if another author doesn't agree.
Okay.
And I'm saying that as the co-chair of the group where that document lives.
I think I got that from Jeff. He said that these things were simple enough that they should go into the base IETF routing as well.
I think that's great, but you got to,
Okay.
but you also said you didn't do it because your co-author didn't agree to it.
Exactly, yes.
And I'm saying it's not his choice.
Okay.
So this topic consistently coming back would be really good if authors of the draft work with I2RS folks to figure out what goes where. So we have clear guidelines.
Those of us who worked on carrier class products know that ribs just tend to expand, and we want this to be a full set, but not necessarily everything that's in a carrier class router. Just a nice base. But I think these things, the things I had before, were things that would be better if we didn't have to augment to get simple things like eCMP.
Okay, I think that was a handoff, right? Good. Let's move on to Sue Harris's presentation on filter-based forwarding, filter-based ribs.
Okay. Ooh, this one's really cool. It's sort of green and yellow here. It's great. Okay. Filter-based forwarding. Okay, first of all, how many people know what filter-based forwarding is? Okay, for the rest of you, let me try to give a bit of information. Now, for those of you who said you know what filter-based forwarding, at the end of the slide, you might want to stand up and say, I'm all wrong, but filter-based forwarding is really packet forwarding. We look at something in the packet and we decide what we're going to modify, what we're going to match on, and what actions we're going to do. How we're going to modify I bet this one has a, oh, no, that didn't do well. Okay. Okay, no, I got it. So you have match conditions, you have action conditions. Now there are 3 places where I have found filter-based forwarding that should be something like the ACLs, and this should be looked at as a filter-based n-tuple forwarding that has additional pieces, and I'll explain why. There is R2S filter-based RIP, which is the same thing, event, match condition actions, and then we have BGP flow specification. The thrilling thing is that I am a co-chair on BGP and a co-chair on I2S. So when I was doing this, I had a moment of deja vu and went looking for the appropriate match filters. Now, ACLs, or I'll also deal with the fact that ACLs plus augments really about equivalent, but I'm talking with a standardization piece that could be shared between all of them. One option is to augment or provide an initial augmentation for ACLs. My initial drafts on filter-based ribs in R2S had this, but this seemed to be an advanced concept. So we can go back to the advanced, but let me do the 101 version. Okay, first of all, I have learned in R2S that it might be really useful to just show what it's going to look like. So this is a proposed hackathon for IETF 96 with features out of the hackathon from 95. 95, we picked up an R2S rib, we put it into the Yang CLI Pro, which is a CLI to netconf translator. Really nice, free. Andy Bierman should be thanked. Then it went down to netconf and hit confd, which is Cisco's free open source netconf server, and we were in the middle of putting Zebra. Well, for IETF 96, we're just going to change a Linux firewall IP table. So that's what we're doing. We're really changing static routes and we're changing filters. It is really basic, but we're doing it via Yang and models. We hope to have a demo and code that can go online, hopefully before IETF 96, but IETF 96. One comment here, this I2R, this model that goes to the IP table is also something that might be used by I2NSF, which is the security management of firewalls. Okay, so what do IP tables look like? They look like, here we have a rule, we identify a chain, and we have an option. Why am I using the basic filter thing? It's just to give you a sense of reality, right? The first option we have in packet policy is that we could do the same rule specification, which is the list of filters. We could have a chain or we could have a table. When I did that initially to match this, people said, oh, I can't really think of that. I want only a top level rule specification and then a set of rules. And the group should just be syntactic sugar that uncovers it. So love some feedback. The reason why we did the chains was to make it, really simple to put into the IP table. So I'd love some feedback on that. Okay, so what's a filter-based rib? Again, it's a list of this policy. With a policy group, we'll use that as a chain right now, so we don't get into any IPR moment. And then it has a default rib in case nothing really matches. And it works across a couple interfaces. It may only work across interface 3 and 4. Okay. Now, why did I do this intro? Because usually in past descriptions of this, people have really said, what is it you're trying to specify? So now, this is another view of it. This is another set of the filters. Now, here comes to the whole part of the talk. I have specified R2S filter-based rib. I have specified a means. Let me repeat this, and if you're into BGP, come see me afterwards. A means that if you are saving filter-based policy received from another peer, a means to be able to save it in the IP table in the same fashion that might be used with someone else, but to be able to track it. So if you have an IP table and you have some that are static put in and some by BGP, there'll be a flag that says, hi, these are put in BGP, because that might be useful to know. At least if I was BGP, I'd like to know, you know, what were there and if I was monitoring. The R2S filter-based RIB was one of our defined RIBs so that you can short-term put one in to handle. Oh, step back. How many people know that a lot of this happens for aiding denial of service or firewalls, right? No? Okay. We are really building a firewall world where the filters for packets might put it in a firewall or might direct it to a particular traffic. So when you look at these three, something that might come from the configuration, might come from I2S, and might come from BGP, I was able to do a Yang model that actually did it. This is the high-level Yang with a single define. So that makes it really easy, okay? And so my proposal to routing is to allow this to occur. I tried to put the Yang in two different data models, but Benoit's got a really cool checker, and he won't let me put this in IR2S and in a routing. So the original Yang model is in the IR2S version of this. So feedback. Where does the Yang for IP table fit? And I'd like to see a single place. And that's the end of my talk. Am I ahead of time?
Yeah.
Cool. So I have time for questions. Oh, come on. I couldn't have been that clear. Oh, AC, good.
AC Lindum, Cisco Systems. This is interesting. I know, we have multiple ways of doing things, and there's nothing really wrong with that. But how do you see this related to the ACL model in NetMod that is undergoing the last? I see you have it down there, but I'm talking not the function, but the model that's
Side by side right now.
yes. Side by side,
If
okay.
you wanted to use it for packet filters, my first draft in this took a really engineering approach and just defined how you would augment ACLs to do it. And I would still augment ACLs and include them, but that would be down in the common definition down here, or it would be a separate one, but it would be underneath the filters. You can do it with the Yang as underneath the type as a choice. So you can't make ACLs into this because there's extra stuff, and I don't want to. ACLs that NetMod did is a really good thing for exactly what it's doing. It defines it, and don't muck with the success. Thank you.
Tom Herbert, Facebook. So speaking of
So that was Tom Herbert.
Tom Herbert, yes.
Facebook.
Facebook, you got it. Speaking of different ways to do it, you might be interested in some of the work that we're pursuing, which is using BPF Berkeley packet filters to essentially implement kind of a match action. And one advantage is it's more of an open-ended programming language, but we believe that this basically is a superset of various other techniques like P4 and probably IP tables and things like that.
Sure.
If you're interested, we can talk offline some.
The IP tables was only there to give something that people know about, and yes, really interested.
Right.
Sounds cool.
BPF's been around a while though. So that's
Yeah, I've heard about BTS. I'd just like to have your information. But for the Yang model, still look good, guys? So I'd like to have some feedback, and if it looked generally good, we'll ask for. Benoit just said, do the right thing, and we'll figure out how to make it work.
AC Lindum. I was thinking about the position of this, and I was thinking the
So that was AC Lindum.
Lindum.
Cisco.
So-
Do you feel like these guys look like talking heads?
But a good way to position is that this includes the classification plus the action plus I think you have some kind of OEM in there too, if I remember right. Some debugging stuff in there too. Whereas the
No, it is simply event match
right.
conditions, modify packet, forward or drop.
Right. Whereas the ACL is just the classification that can be where the application is dependent on how it's used. So
That's right. That's how come you can use the ACL for the classification and the match. And Boy, great minds think alike. Am I done?
Do you plan to include operational state counters, hits, misses? Operational state.
First, I wanted agreement on this, and then we'll add operational state. Don't run before you can walk, and yes, operational state. Actually, I may have in this version some beginnings of operational state that count the number. I just can't remember. I had all this in the first version, and people said, say what, and I've been pulling things out. It's not hard. You just say, here's the filter, here's the op state. And I have it at least in information on BGP as well. Okay? So good question. Really good question, Jeff. That was Jeff Tensera.
Oh, and we also have Chris Hops at the queue, so wait. Please wait. We have one question here.
Hi, Chris Hops,
Chris
Deutsche
Hops.
Telekom. Okay, so I guess my question is, did this come first, or was this sort of driven by flow spec? Because I see that it seems sort of natural to flow, to come out of that, where you have different protocols adding filtering or filter-based actions.
Yes, both. I've had people say it was one then the other, and then I think it was a very creative mix, Chris. I don't really
Okay.
know who did it first.
Who came first? Okay.
When we did the Charter edition for I2S, we had known about BGP flow spec. BGP flow spec is way, what, 5, 6 years, John? How old is BGP 5575? 5 years, 6 years?
Well,
Yeah, so BGP flow spec was definitely first. Our use of the two Yang models are the R2S model came first, then the BGP flow spec, and then the routing. As far
Right.
as
So,
what
the reason
produced.
the reason I ask is I'm curious if what other, this is a very valid use with the flow spec and wanting to know where these things originate, right? I'm just curious if there are other things other than like static config and flow spec that might be adding things to the IP,
So as far as R2S adding, are you asking if we have more filters that might be adding stuff? The answer is I actually know that I've got info models out of I2NSF for the security forwarding people.
right.
If you're asking if there are ephemeral models, that too is a good question. Both of these are great questions, Chris. Thanks for participating remotely. You get my award in R2S for asking some of the best questions too. We designed I2S to be able to add, or the R2S working group designed R2S to be ephemeral at any point you want. So if you want to add ephemeral to any of these models, there's an easy way to simply say this is an ephemeral piece and you can add it. Did I answer all the questions or did I miss it, Chris?
I think mostly. The security
Okay.
thing was cool. Okay, thanks.
Thank you, Chris. Thanks for helping us out.
Yeah, thank you, Sue. So now we have AC and Lou in some order presenting on the output of the routing area Yang architecture design team and also on the device model. I've asked both of them to actually give some concrete advice to authors of Yang models because there were some, so AC's presentations were great, but he also said some things like, well, obviously we need to wait for op state changes, or he has an intuitive understanding because he's on the design team about what changes are being done in NetMod that affect models. However, I think there's a large class of authors of Yang models that really don't care too much about what's going on in NetMod. They're experts on their technology area, and they would just like some concrete advice about what to do to model their technology. So I've encouraged Lou and AC to give some concrete advice, even if it's not technically in their charter. It's not normative advice, but it's advice nonetheless.
Thanks. First of all, Lou Burger, individual, says we're all individuals here. Right?
Just one thing. If you're going to do this experiment, don't make a joke out of it.
Don't what?
Otherwise, I mean, this whole thing about repeating it 3 times and so on, it's getting really old. Can we please not do that? I mean, either just do it the old way or don't do it.
So, yeah, I actually would like to continue to conduct this experiment because for people who have been doing IETF stuff for 5 years and know everyone in the room, it's one thing. But if you're a new participant, you actually need a mechanism to learn who's at the mic. And so I think this is a reasonable thing to do, but let's hear from Aaliyah here.
Aaliyah Atlas. I think it's a really good idea. Most people mumble their names. I would like to get to see, understand and know people who I don't have time to have an individual conversation with. It's really hard when I heard was mumbly fnarsh groups.
So I agree with that, but saying it 3 times and acting like it's all a joke. No, it's not a joke. I think it's a really good thing, but keep with the experience. Say your name clearly. My name is Michael Abrahamson. You repeat it, fine. Don't make a joke out of it.
So the point I was making is that we're supposed to be individuals here. And repeating our company 3 times or 2 times or whatever is a little grating. I normally just let it go. But since I keep hearing an echo of company names when we're supposed to be individuals, it was grated on me. So that's the point I was making.
So Julius Krobacek, and if I
So that was Julius
Krobacek.
Krobacek.
Well done. So if I may just add a comment, in this particular session, we have a very good Jabber scribe who is quite systematic about giving people's names. So if you don't follow the names, it is quite useful to be on the Jabber chat room because you will have all the names written down.
Well done, Jabber.
And it's easier if you stand at this mic because then I can actually spell it right. I don't know if I got your name right.
Yeah, quite seriously, well done, Jabber. How much time do I have now? I think we asked for 15 and we ended up with 45, which is okay. It just means you'll spend more time on it. We still have 45, cool. Please let me know if I'm going too slow or fast. All right, so this is a report from the routing Yang design team. We have 2 parts of it. We have the first part, which is a status update for the whole design team. And then we have a second part, which is diving into the draft, which is done by a subset of us. The subset of us that are in the room include AC, so he'll correct me where I'm wrong. And we also have Chris remote, and so he'll jump in. Although I will feel like the blue ghost coming after me. I'm not sure if I'm the Pac-Man running away from him or not, but whatever. To address the chair's request for direction, we will. I'm going to try to pepper that in where appropriate. But there's actually a meta point here that's, I think, an excellent one, where we in the routing area, we know how to do routing protocols, and we don't. Most of us. Don't really want to spend all our time on Yang, although I don't know, I got roped into doing that. But it is useful to point out to the group that defines the defines Yang and defines Yang guidelines. It's useful to point out to them where guidelines would be helpful. And this isn't something that necessarily the design team can do alone. We are trying. But if you have if you're new to Yang, you have a protocol, you're trying to fix something, and you're not sure which way to go, please send a message to the netmod list saying, hey, we have these options. What's the right convention we should follow? And there's an update going on of an RFC in that working group, which is guidelines to Yang authors. So first of all, if you're not aware of that update, please go read it. And second of all, if you think it's lacking, please ask for guidance, and hopefully we'll capture that in the document. I think that's a really important process, particularly to us, users of that group's product, where we're defining new Yang models. We really don't care which of the flavor of 3 different options to do the same thing to follow. We just want to know which, and then we want to do it consistently across the area. So we'll try as the design team, but we also need your help. Next. Oh, that's me. So the design team had sort of 3 areas of work and still have 3 areas of work that we're focusing on. The first one is related to the overall meta model, and this has led to the device structure draft. The second is op state, which we all know and love that discussion, right? Well, maybe not. Maybe some folks haven't been tracking it for the last year because, this discussion, while we've spent a lot of time on, really only has been going on only 1 year. So it may feel like a long time, may feel like we've had a tremendous amount of discussions, and other groups have had a tremendous amount of discussions, but from a standards standpoint, it's really not that long. We've made really good progress. We need to figure out where to go with it. And from our standpoint, we're more on the user side here. And the last one is conventions. We already spent time on that. So the meta model, you saw at the last meeting that we had an approach that lived within the context of the existing Yang semantics. And it was a bit invasive, let me put it that way. In particular, you would, in order to conform with it, you would have to modify every Yang model that existed as well as almost every Yang model that was coming. We, as the design team, identified that that is not really a good approach, not a good idea. We talked to a number of folks from NetMod at the last meeting about a potential way of doing things differently. We called it Mount Prime, Mount Plus, Mount whatever, and it's come up being called Schema Mount. And this is something that is moving forward pretty rapidly. I'm going to talk later about how it impacts and simplifies our model. The key point here from a status standpoint is that we've been, by working with the NetMod contributors and working group, we've identified a way that radically simplifies the approach to address our requirements without having to go modify everything out there. That's a huge win. And we did an update assuming that that solution is going to be there. So this is a little bit different, where often you'll say, okay, the solution is well mature and we're going to leverage it. This is saying, yeah, it's a little immature, but it's so important and it brings such value, we're going to jump on it before there's even a working group document. In terms of the design team, not the author of the documents on the next presentation, the design team is going to be tracking what's going on there and talking about it more. I'm not, this is, AC's talk in NetMod was the start of that, talking about it more, but a lot of that discussion is also happening just with other authors. Given that we've seen that, or I've seen that the use of schema mount is showing up already in other drafts, it looks like I'm not sure how much more talking was really necessary. People get that this thing is a big win. That said, don't go crazy with it. Think about where it really is useful and use it only there. From op state, from the design standpoint, design team standpoint, we've helped make sure that the requirements are understood and socialized. And that's primarily been within the NetMod working group, but we as a design team certainly have been very focused on helping that be understood. In some discussions, since the requirements document was issued by NetMod, since it was issued, we've realized that one of the use cases, one of the very important use cases for op state was not understood by everybody. We thought it was documented. It wasn't, it was discussed a little bit, but the implications, it turns out language is important, right? When you phrase something a certain way, you think you're being clear what it means, and people don't always get it. And so we're talking about the requirement for not being, I think the old language was not being protocol based. What that really meant is we really needed a solution that was supportive of telemetry, and a telemetry-based application where you could basically subscribe to a node in the tree and say, send me all updates based on that. And that was not a requirement that was necessarily well understood or well supported in the different options. The The NetMod solutions authors are working on a consolidated approach or a joint approach. There were 3 options that were put out in that group. As the design team, we're just sort of watching that. And if you're interested more in that activity, NetMod is really the place to go for that. The lack of, and this is going to get to a little bit of a recommendation, the lack of an op-state solution is really hurting everyone because we're not sure what to do. Some drafts and some model writers have gone and decorated their models in the way that the OpenFig guys have recommended, where you have intended, applied, as well as derived state. Others are waiting. It's our recommendation at this point that for intended and implied config, you wait to see what happens with the NetMod authors that are working this, and wait until Berlin. Give us until Berlin, and let's see what happens there. If you have already put in these things into your drafts, leave them there. If you haven't, don't. That's our recommendation. It's not a requirement. You said we're not mandating anything here. Right. You got it just right. So we're in complete agreement. This is just advice. Now that is related to intended and applied config. Derived state is something that you can't use an algorithmic or a tools-based approach to solve. That's something that requires the model designer to really understand what is important derived state and to organize that properly. So we do think that that's important for model writers to act on today. We are not at the point of saying follow the conventions that have been put forward by OpenFig. We're not saying at the point of saying don't follow them. We are at the point of saying do something. We think that this is a good point to bring up to NetMod and say, hey, what should we do here? What's a good convention to follow for the routing area? I hope that was clear. Did I sufficiently address your question?
Yes, I think so. Thanks for the concrete advice about leave it as it is for the moment. Whatever choice you've made in your draft, don't waste time changing it.
For intended and applied. For derived, make sure, put something in.
Okay, thanks.
Yeah, derived, you absolutely want to put something in.
AC Lindum. One point I'd like to make, and this is based on.
So that was AC Lindum, and we're actually requesting that you just say your name once, and then I'll repeat it so that other people can understand it. Thanks.
That's good. One point I'd like to make, and this has been a consistent theme, is we are trying to work outside of these 2 weeks. We're meeting at least every 2 weeks on this op state, and like I said, we're watching the solution offers. Neither Lou nor I are authors of any of these op state solutions, so it's not like we're not working between IETFs when we said just give us some time.
Yeah, and unfortunately, I wear too many hats now. And us in that context was let the NetMod working group have some time. And like the design team is meeting every 2 weeks, the model, the solutions authors are also meeting regularly. I'd love them to meet every 2 weeks. Unfortunately, it's not that fast, but they are also meeting regularly, and we'll be doing interactively talking about options. Some of it is even happening on the list, which is great.
So if I've got a set of, excuse me.
So this is Sue Hares.
I'm sorry. So we've got a set of models in R2S that are getting close to ready to go and have been sitting on the off state for a while. Do you have a ETA, or there is no ETA?
So the hope is that by Berlin, there will be a NetMod working group document that captures a single solution to the intended versus derived state issue. There'll be a single solution, a draft with a single solution as a working group document in Berlin. That's the hope. That's a, that if the stars don't align,
Yeah.
we'll be saying, we'll have to figure out what to say in Berlin.
Okay.
But right now we're saying, give us until Berlin. And us, again, is give the solution authors plus, and I'm not one of those authors, by the way, plus the NetMod working group until Berlin.
Thank you.
And if you were in NetMod, you would have heard the AD there talk about how these two issues, schema mount and op state, are blocking everything right now, and it's a big deal, and there's no higher priority for that group than solving those two problems.
Thank you.
Shifeng Liu from Ericsson.
Shifeng Liu.
Yeah. Lou, you mentioned that we can go ahead to do the derived state. But even for that, we have several options and the different kind of structures. So there's the open config people suggested is very different from current structure. So even for that one, I feel like we need to add to the list. So that probably either after apply state or doing that in parallel, but that also need to be resolved.
Right. So this falls into the conventions or guidelines area that I talked about earlier.
Right.
And one option is certainly for the design team to take that specific point back and say, NetMod, what's the recommendation? That's one option. Another option is that those people who are actively working this problem describe the specific problem in NetMod. I personally think both are good approaches, because while the design team can talk in abstract and say this is an important point to the area, the individuals working the problem can describe in specific exactly what issues they may have. Rather than us doing just a theoretical description, they can do a very specific description. So I think both conversations have value. So I think it would be great if you could take the model, one of your, 5, 6 models? It's good. One of your models and say, hey, I have all these models that have this problem, and here's the problem from one of my models, and bring that up on NetMod and say, what's the guideline of the working group? I think having that very specific example will help facilitate the discussion and force a resolution on the consensus of what the guideline should be.
Yeah, sure.
So thank you very much.
Lou, Justin Sure. So there's a lot of work going in routing area where people are implementing derived state as we speak. Do you have any recommendations how it should be done now, since it is done and we are doing it as we speak?
I tried to say it before, maybe I missed, but we're not at the point of having agreement in the design team of a specific way to recommend derived state. We have some folks that come from an open config perspective. They of course really like their approach and think that that should be followed unless there's another reason. We have others that aren't quite at that point. But frankly, the design team has been focusing on the first two problems more than the conventions discussion. So we as the design team do not have a recommendation at this time.
Would it be fair to say wait till Berlin? Or?
No, I think the right thing there is discuss it aggressively on the NetMod list and try to help push. Do not wait for Berlin on this. On the whole convention topic, do not wait for Berlin. Jump on the list even today. Help that group identify the areas that it's important to the routing area to have conventions. We've talked about this as at being dual-hatted. I was able to talk to the author of the BIS document and have him consider and then be willing to take on additional conventions and guidelines. He talked about that in NetMod. So based on the design team's work, we've identified it. The group has agreed to take on more. So it's at a good point to go talk about what conventions you need.
AC Linda, that's the 6087 BIS document.
Right. Andy Bierman is the author, but it's a working group document, so comments really should go to the working group. And you don't have to reference the BIS if you say, we need some help on a guideline or a convention. That discussion will end up in the right place. If the list gets really long, it may be that it ends up in its own document, because there is a strong desire to get that BIS out before Berlin, but we're going to have conventions that are going to keep rolling in, and we got to figure out how to deal with that. And I don't, from the NetMod side, I don't think we have the answer to that yet. But get your conventions going. So this slide was originally put in at the based on a request from our AD in a discussion of what do you want the design team to do next. Clearly, conventions is a hot item, so she was right to say that this is something that's important for the design team. One of the issues here is going to be how much is happening in the design team and how much is happening in the area.
So actually, we have someone waiting at the mic here, one of your co-design team members. So I'm going to buzz him in.
Hi, yeah, so I just wanted to address I sort of wear two hats as well because I've been working with the OpState authors group. I think derived state is actually one of the last remaining hurdles for the OpState solution. So Lou saying that, go to the list, will definitely apply pressure there. But it really does have to do with where derived state is located with regards to intended and applied. So yeah, hopefully we have an answer by Berlin. I don't think you should wait, but it is one of the last remaining issues, I think. I think that was all I wanted to say on that. Yep.
So I think the last point I want to make on conventions is I think there's a little bit of a tension here between doing work in the design team and doing work with having more participants. This is an area where I think the answer of wait for the design team isn't right. Yes, we'll continue working and we'll continue working the high level issue, but if you have a specific issue on a convention, we think it's really important to start discussing it now. And so don't wait for the design team. We don't want to be the gatekeeper here or the gating factor here.
Oh yeah, yeah, the point of the design team is to make sure that somebody's thinking about it, not to stop other people from thinking about it.
And that was Aaliyah Atlas.
Sorry. And the second, and to be sort of the scribe for what the different conventions and discussion are and help grip it together. But the folks who are writing the models are the ones who run into the conventions. You really need to be thinking about not just, we don't want write once Yang models. We want Yang models in a system that's going to live and work with the IETF. You probably remember discussions about manageability sections from those who had been around for a while, and I don't think we want to go that direction, but I'd like to have some thought about this.
Yeah, and bring those thoughts when you're not sure. Bring it to this list, bring it to NetMod, but discuss it publicly. Would be really helpful. I think we've talked about that enough. So now moving into the document itself. So there is another open question if we're looking at the document. So just to be clear, this is a subset of the design team are actually actively writing. The whole design team does look at and is able to comment. Sometimes we get more comments, sometimes we get less. There's another open issue here, and I'll get to it at the bottom. So the document talks, the new version of the document is really broken up into 3 sections. There's the base network device model, where we're using Yang as a mechanism to describe a organizational structure rather than a specific model to be implemented. This is the core of what we had previously seen in terms of organizing the protocols and the different system services that you expect to have on a network device. What we've done is based on the introduction of schema mount, we've broken out the parts that support logical network elements and the parts that support network instance, which is really just what you have, what's been in the past called routing instance. We've generalized it to support VRFs and virtual switch bridges. So we call it network instances. Those two pieces have been broken into their own individual models. We think that going forward, these will eventually show up as 3 different documents. One document is the network device document. The next is a PS document, a standards track document that defines support for logical network elements. And the third is also a standards track document that supports network instances. I'm blanking on if we have another slide on this because I'm confusing the 2 different presentations because we had a slightly different version for NetMod. But when we break these up, it is pretty clear that the last 2 belong in this group, or at least it's my perspective as an individual contributor, that the last 2 belong in this group. The top one, there's a bit of an open discussion to be had, and some of that discussion took place earlier this week. And the question is this network device structure, where we happen to be using Yang to describe something that is never implemented, maybe it's more of an example, is that just something that we think would be useful for model writers to consider, but there's no requirement? That's option 1. Option 2 is this is something that the IETF believes is very important and will enforce for at least models defined within the IETF. If the latter, that's really a broader conversation than belongs in excuse me, the routing working group. We don't really have a strong position as the design team. We started out having a very strong position when we wanted to put everything under /device. That we wanted to be a mandate. Once we agreed that it's not a mandate and moved to schema mount, our opinion sort of went, it could be either way. So we certainly look to the chairs or AD, the participants in the group, to voice an opinion. So that's a thought. So we really would like to move the last 2 into being working group documents. One of the questions at the end, in 18 minutes, something like that, 17 minutes, will be what the chairs want us to do. Do you want us to publish each of these individually as their own documents and then go to working group adoption poll? Do you want to poll what's there with an understanding we're going to break apart? What do you want to do? It's your call. You don't have to give me an answer right now, but in this session, that would be one of the key questions we want to answer. So we've talked about the whole concept of logical network element at the last meeting, maybe the meeting before where we did a deep dive. We're not going to go through that in detail now. What we are going to say is that we've maintained the ability that the host system, the base system that hosts these virtual devices, that the host system can manage the logical network element, or the host system can have an unmanaged logical network element. We had previously defined a couple of different ways to do it. Now there's basically a Boolean that says managed equals true. But so we still have preserved the ability to have a host router or a host network device have virtual network devices within it, and we have these 2 options. We think that this is much more aligned to the full range of implementations that may be out there. For instance, this will work just fine for a NFV host system. The base host manager, as well as the VMs underneath it. It would work well for that. It would also work well for some of the older implementations that treat the hosts as fully managed, the logical network elements as fully managed devices, and everything's managed top down. It works for the full range there. We've used the same technique of schema mount to support network instances. There is a difference here, is that they are always managed from the above the root of the mount point. So our challenge was with the previous version that we talked about at the last IETF is that we were mandating a structure that would have to implement every model that was out there, not only the ones that are coming from IETF, but also the ones that are coming from other SDOs. We sort of felt stuck. We felt that this is what Yang semantics allowed us to do, and we didn't like that answer at all. We thought it was not really a good way for, wasn't a good industry solution. It wasn't a scalable solution. It was putting in too many stumbling blocks, and it was way easy to get wrong within the IETF. And you know, we tried to do the cross SDO thing. It was just going to blow apart, and that led us to come up with a better idea. So this was the original. So the better idea is we rely on something called schema mount. Schema mount allows any model to be, or really schema, to be mounted underneath another schema. Think your file system. It allows you to do basically a local mount. One of the things that is important with schema mount that differs from what you would do in a file system is that when you do whatever operation you do to instantiate the tree underneath the mount point, you're actually instantiating a new data elements. So you're not pointing in Yang and netmod, netconf, we love talking about data stores, right? So you're not instantiating, you're not referencing an existing data store or sub-data store, you're creating a new one. And that's a very important difference with schema mount. So when you instantiate the mount and the models underneath, or the schemas underneath the mount point, you're instantiating new data elements, and you can reference them there. And that's the scope that they exist. If that mount point is destroyed because you're destroying that VRF, all the data goes away. We still have the model 1, which is well-defined in Yang. It's not intended to be implemented. Maybe we'll label it as example based on this meeting. But we have the notion of a top-level device, and that top-level device has within it a number of top-level modules. And by top-level, we're referring to the path, the XPath. And you can see an example here where ... is what we mean by a top-level module. So we think that certainly we want to reuse the ones that are defined. We think that also having groupings of them, like for instance, all your different OAM protocols being underneath OAM, that's a valuable concept. Whether that's done through the path mechanism, where we actually mandate that all OAM protocols have to have OAM in the path, or through some other mechanism, for instance, metadata within the Yang model that says this is a type OAM or it's classified as a type OAM, doesn't really matter from the design team standpoint. From the design team standpoint, it's just important that you have these logical groupings. So you can see what how we've broken things down here. A number of these are existing models. The first model I really want to highlight. The first model is something called Yang Library, and it allows a client to understand what the netmod server is providing to it. And there's other ways in doing it in Yang, but this in particular gives more detailed information than you would otherwise get. And we are going to reuse that in a moment when we talk about the bottom two elements with logical network element and network instance.
Jeff Haas.
Jeff Haas.
It sounds like the primary property you're looking to get here is to provide associativity between modules. So you can tell by looking at a thing, for example, this is an OAM protocol. We have the Yang catalog stuff, which is giving us the ability to look at stuff in the system. Does it maybe make some sense here, there, or potentially somewhere new to simply come up with like a keyword hashtag type mechanism to say this is a classifier that you may choose to associate your module with?
Yeah, and that's what I meant by I was referring to a metadata-based solution. So I think if Chris was here, this is where he would jump to the mic, and Chris will correct me maybe if he's wrong, but he would jump to the mic and say, the reason why we want this as a user, I'm not coding an NMS or whatever controller that's using this, so he's the best one to make this point, but he's not here, so I'll make it for him. He would jump to the mic and say, the reason why it's important to have these groupings is because then you can do classes of handlers, or you can write classes of code that understand that class of model. And that it's much better to have the ability to immediately identify the class so you know what type of functions you're going to apply against that model, rather than have to have hard-coded catalog that does that mapping for you in your implementation, particularly when new things show up. And if this is done well enough on the implementation side, when something new shows up, maybe you can do something with it even though you don't fully understand it. So that's the reason from the user side why it's important. In terms of the implementation side, so this looks, what we have presented here looks like it's going to use the XPath, whether we use it through metadata where some sort of tags like classification. I personally don't have a strong opinion. I don't think as a design team, we haven't discussed what's the right answer for that. I think we will come to the answer of, sure, give us a solution.
And it was the XPath comment that actually made me ask the question, because if you actually have a common leaf list type element where the stuff actually could be matched, it's possible to craft an XPath that says, give me the list of all modules that are tagged OAM.
Right, and in fact, when we presented this the first time, one of the Yang doctors came up and said, oh, you shouldn't be getting these the specific names of all your protocols, or actually just use type, and then you can define new types and you can iterate over it. And so they took it even a step further. Mm-hmm. Now, whether or not the metadata-based approach lends itself to that, I triggered Chris. Cool. Whether it lends itself to that or not, that's something that we have to dive into the solution. So we're really saying this is a logical structure. Don't implement it. And then we're working with NetMod of figuring out what's the right way to implement it. Do you actually put it in the XPath? Do you put it in the classification model? Do you do some new type of, I think that again is metadata, but a new type of tag, hashtag is great.
I'm going to buzz Chris Hopson as well, because he may want to respond to this.
Hi, Chris Hops. Yeah, so, right, I mean, I would add a lot of maze in what Lou said. I mean, I see this as a feature, being able to do a wildcard path under, I mean, this is not a very useful example, but routing protocol star hello interval, right? I mean, I don't know why you would use that, but you can see how that might pull all the hello intervals from protocols, even ones that you didn't know existed. I don't know, that's why I say may be useful, right? One could imagine this being useful. I hadn't actually heard about the metadata idea. Perhaps there is a way to do a similar thing, right? If they were all sort of root mounted, where you could just say, give me all routing protocol tagged things and show me the hello interval. So it could be that both solutions sort of work for that.
Yeah, the metadata was pretty, Chris, the metadata idea was pretty new. It came up in the NetMod session earlier this week.
Oh, okay.
So.
Also, I wanted to just jump in for a moment. We have 5 more minutes because we're going to start the ILA presentation at 11:30 so that we can finish it by noon, which is our total allotted time.
Okay, don't kill me yet.
AC Lindum?
Oh, AC, one second, AC. The other thing I was going to say on this is that there are strong opinions outside of the routing area that don't want this. That, I mean, at least this solution of having suggested paths. There are people that really don't like that. They like the loose coupling, and they'd like to see all models sort of just you know, at the root. So if you do have an opinion, you might want to pay attention also in NetMod, not just here, because that's where those strong opinions against the structure are. That's it.
AC Lindum, the challenge is the design team.
This is AC Lindum.
Right. The challenge is the design team sees to having a normative device model are one, agreeing on the hierarchy, and two, the logistic problem of having all models have to augment those categories. And like Chris said, from a logistics standpoint, having everything be independent of this has a lot of advantages.
I presented filter-based ribs. Would they go under the filter-based policy? Would that go under ACL, or will you create a policy-based thing?
So and that question was from Sue Ayers.
Yes, thank you.
I think it's a great question, and it highlights the problem with this approach. That's, you know, so particularly coming after AC's comment, which I thought was dead on, and Chris's comment, it highlights the issue if a structure like this.
Yeah, it would be beneficial to.
Anytime you look at a model, you got to go figure it out, and that's sort of why I like the metadata approach a lot better. It came up on Monday. The design team hasn't had a chance to meet and talk about it, but that might be what we decide, independent of what the NetMod group decides, if that they want a firm structure or not. We may say it's actually better to use a metadata approach, or approach where we call it classifier. The classification model is the existing one, but that's very coarse. Maybe we have one which is routing classification or routing metadata or something like that. But
Chris's idea would work well for the ACL, and Chris's idea of having sort of a general higher level would work well for the ACL and the packet filters. It might be useful.
Okay.
Might have some.
Thank you.
Hi, Dhanendra from Cisco. I wanted to bring up a scenario.
Could you repeat that again?
Dhanendra Jain, Cisco.
Dhanendra Jain?
Yes. I wanted to bring up a scenario where, for example, a couple of entities within the device level, like such as routing is one example, may need to refer and associate it with certain elements within network instance, because network instance will be used to model VRFs, PRFs, and then within routing there may be configuration to go under a context of a VRF.
Sure.
Such as the tables and neighbors under BGP valid only for VRF, and then repetition of those for another instance of VRF, for example. So keeping routing separate from network instance, we would need a way to associate these two.
Right.
And refer these two.
Yeah, absolutely. So there's cases where you need to refer items that are in the parent down to the child. Just think tree. So you have cases where you have to go from parent to child. We have an example of interfaces that you can look through the document to see how that works. We also have the notion of that within one of the mount points, that everything under that mount point could be the whole system. So it's a recursive model. So at least the logical network element is fully recursive. So anything that you need there is instantiated there. And it's instantiated based on what settings happen at the parent. So we think we have it covered. We now are pretty much out of time to go into detail, so I can't walk through that. What I was going to do is, based on the time constraints, is show a little bit of the overview on this slide and then jump to the last slide to make sure we haven't covered any other open issues. But it's a really good comment, and it's a really important thing to understand. And there's some subtleties in this, and you really got to go look at the draft, understand what's there. And we're all 100% sure that it's not as documented as well as it could be to have a new person who's not spending all their time on it understand. So if you see something in the draft that it's not clear, send it to us, send it to the list, and then we'll try to address some text and work with you to get some text in there to address that comment. Because as I said, we're 100% sure that we could add more informative explanatory text. So thank you. So look forward to seeing the message on the list. So just briefly, when we start.
Yeah, so we'll give you 1 more minute, but no more questions
Okay,
because
so
we don't want to cut into
given
Tom's
that-
time.
Given that, I'm going to skip the details and just go over this slide. So where are we and what are our plans? So we are relying on schema mount. It's blocking us. NetMod gets it. They're working hard on a solution. A working group draft was adopted on this, although it doesn't have a specific solution in it yet. They just know that that's the foundation. So that's proceeding. It's going to be really important to align with whatever's happening with the op state solution piece there. We're in the same holding pattern, but obviously going to help support that activity. Chris is participating as a member of the design team. It's hugely helpful. Is there anything else that's really important to hit here? The last couple are related to this point that we've talked about with XPath versus metadata. So I think we covered the main things we wanted. As we know, we can never go as deep as we'd like in these discussions, but good discussion so far. Please send us more detailed questions on the list or suggestions too.
Okay, yeah, let's go ahead and transition to the next presenter, who is Tom Herbert, and he'll be presenting on ILA. I can also, while we're doing this transition, address your question about what format you'd like us to, or you would like to have the document in. Really, whatever you think is both easiest, but will also result in the easiest for the working group to figure it out. Because you could keep the document as is and describe how you're going to divide it up, but you might find that in doing that, it will just be easier to just divide it up instead of describing how to divide it up. But make that decision, and we think this document has had enough vetting that we can deal with either scenario.
All right, so we'll have our first design team meeting, and then based on that, we'll say whether we want to break it up or keep it in one for now. Thank you.
Correct.
And thank you for remembering that question, because obviously I forgot.
Good morning. So my name is Tom Herbert, and today I'm going to talk about identifier locator addressing. We had actually presented this in B6 Ops in Yokohama, and I think earlier in NVO3. I'm presenting here today, hopefully it gets more general audience, and we are looking for some feedback on basically what to do with regards to IETF for this. So we actually have 4 drafts that I'll be kind of touching on today. The ILA draft is the main one that kind of describes the protocol, and we added a messages draft which will describe the redirects that I'll mention in a bit. And then Peter Lapikov has done 2 drafts really on the deployment side and some extensions to BGP. So the motivation for this project is what we're kind of calling object virtualization. And the idea is that we want to be able to address many objects in a data center. This is probably going to go beyond VMs. At some level, we want to address kind of the micro addressing of objects. And one of the important things is we also want mobility of these objects so they'll move around the data center. So you can imagine now we have VMs that can migrate. In the object world, a VM would be an object and that would be migratable, but there could be other objects or things like containers that we want to migrate. Scale is very important, and we're talking pretty big scale. Initially, it will be in the few millions, but as we go on, we do anticipate if this object model kind of prevails, we'll have in the tens of billions, possibly even hundreds of billion objects. So this will be a very large scale sort of thing. The 3 examples that I'll give today, our primary use at Facebook really right now is to virtualize tasks, which are essentially containers. This is related to the more canonical view of, I guess, network virtualization, which is VMs, which could also fit into this model. One of the newer ideas that we haven't actually thought through, but this came up in the 5G working group or BOF the other day, is applying some technology like this to IP mobility in a more general kind of use case. So I'll give one example with some specifics. It's task virtualization. What we're looking for is a capability that every task in the data center, which is basically every unit of execution, can seamlessly be live migrated, moved around, basically separate identity from location for these tasks, so we have that freedom. And this arises from kind of a well-known scheduling issue that large data centers will have. And if you can imagine a data center, we have a network fabric, racks of machines, and each machine can run so many processes or tasks at a given time. And we have a distributed job scheduler whose job it is to try to schedule this per the resources, per the requirements of the applications. So the problem, though, is it's very inflexible in a specific sense, in that if we schedule a whole bunch of tasks and then something more important comes along, or we find out that our scheduling was suboptimal, what do we do? And in most of the current models, we don't have much recourse except to kind of kill the existing task, lose the progress, and reschedule them. So there are some ways around this that people have tried. Checkpointing. Today you could actually run this in VMs. VMs provide some live migration. But those sort of things entail overhead. They're typically not seamless. They're performance intensive. So the model one of the models we're looking for in ILA is to do task migration. And this is where we get into the seamless task migration. So if the job scheduler decides that there's a better way to schedule the task, maybe the job scheduler can just move the task around and optimize it, the network and resources in a better way. So the underlying technology for this is actually something like ILA, separate identity from location. And there's obviously another layer to do task management, migration. So it's fairly complex and a long-term goal. But after migration, if it works out, now we have the same task running. We added the new ones where they belong, where the resources allocation is optimized, and we can go on. So this kind of leads us into the requirements and assumptions that we need for our solution. And the first requirement really is something that's transparent. So the example I gave is something that we want to run data center wide, and it really is about taking existing applications and running them with this new capability. But as far as the application is concerned, they don't know the difference. No performance hit, they don't have to do anything special. It really needs to be transparent. Along those lines, we really want zero performance impact, except when migrating, then obviously migration will always take some overhead. As part of zero performance, we believe that no on-the-wire overhead is a good thing. And that also leads us into compatibility with the existing solution in terms of network offloads, routing in the network, things like that. So we want to be basically compatible with the existing technology, require no new hardware, no new software beyond the services provided by this kind of service layer. ECMP, NIC offload should work. And one assumption that may be a simplification that could help us, especially in the scaling, is that most objects will never be migrated. So it really is that we have the capability to migrate, but obviously, if we can run, let's say, a task to completion on a single host, that is optimal. So we still want to try to avoid this, but it's good knowing that we have the capability, and this will actually open up a lot more flexibility and opportunity for job schedulers. So the ILA solution is to split the IPv6 address into an identifier and a locator. And this is very much like ILNP, and in fact, we kind of did base this on ILNP. I'll get into the differences between ILA and ILNP in a minute. But each object in the network would get its own identifier that tells the who part of the address. And then the locator is basically the part that says the where, and that would be On the wire, that would be the physical location. So what this entails is a system where we have mappings of identifiers to locators. This is precisely the same thing in network virtualization, where we map virtual addresses to physical addresses. So in order to send, from one host to another using ILA, there's a mapping that occurs of essentially a virtual address to the physical address, which is overriding the locator. And the key thing, though, is that the identifier part is basically persistent for the lifetime of the object. So the identifier identifies the object. And in the case we migrate an object or move it, say, from one physical host to another, the identifier is always constant. And that's how we identify the endpoint, basically. So this kind of derives an ILA topology, and this is kind of the abstracted model. We do anticipate that we want to have both, say, ILA host, non-ILA host, and the non-ILA host should be able to talk to ILA host. So that implies that there would be some sort of translation happening within the network, which we're calling ILA routers, and I'll get a little more detail on that. And also, there will be some concept of ILA domains where the identifiers are specific to the domain. And obviously, if we cross domains, the identifiers aren't necessarily unique, so there would be some translation that may have to happen. So the address split, like I said, it's very ILMP-like. We split the IP address right down the middle, 64 bits for locator, 64 for the identifier. The locator is routable, basically to a host. That is not used in layer 4 or as connection endpoints and not visible to the application. The identifier portion is 64-bit logical address, and we actually take out 4 bits. 3 bits are a type field for different types or modes of identifier. And there's one other bit that helps us with checksum neutral translation. The identifiers are not really routable, but they are used as a connection endpoints. Now, as I mentioned, the identifier is visible to the application, and in order to maintain compatibility with applications, we still want to use IPv6 addresses. So what we did is, in the place of the locator, we used what's called a SIR prefix, standard interface representation. This would essentially be a common prefix in a single ILA domain that all of the hosts would be aware of and all the hosts would use. And when a host, for instance, gets a address out of DNS, it would be a SIR prefix name, which means we have this generic kind of common prefix in the locator portion, and then the identifier actually identifies the end host. And when the host sends, at some point, in order to deliver it to the actual destination, there's a translation that occurs in the, say, the destination address of the SIR prefix to a locator. Locator address is the physical host on the network. It's delivered, and then at the physical host, that's the destination, it actually does the reverse translation, gets the SIR address prefix back in the address, and that's what's delivered to the application. So application never sees the actual locator. That does imply that the translation is basically symmetric on both sides. So network virtualization, this is somewhat more along the lines of NVO3, where we have a virtual networking identifier and a virtual address. I'm not going to say too much about this, except that we do have an encoding. IPv4 is really simple. We can actually fit the full IPv4 address space in an identifier, plus 20 or 24 bits of virtual networking identifier, all with an IPv6 address, so that works out great. IPv6 is a little trickier. If we actually want to encode 128 bits within 64 bits, obviously a mapping issue, so we do need to do a little trickery, but I think we have a reasonable solution to that. There are also other nice things. So ILA will allow VMs in a data center, say in a virtual network, to actually talk with services outside of its virtual network using ILA and similar to the internet. And this also would allow us a nice way to have two VMs and two different virtual networks to basically talk to each other given some policy. So some of the details, as I mentioned, there's a mapping of identifiers to locators, and this is logically the same sort of mapping that NBO3 uses. And in fact, the control plane for network virtualization, canonical network virtualization, should be pretty much identical to a control plane for ILA, except the differences would be the address format. An important thing is that the translation can happen at the end host or in the network. In NBO3 parlance, this would be at VNEs, basically, which could be co-resident with the host that's using the virtual network or virtual addresses, or it could be somewhere in the network. In order to facilitate that in the network, we have this concept of ILA routers, which is basically, like I said, VNEs. And there's also a concept of redirects. So our preference, obviously, is that if we have an ILA-enabled host and it's sending through a router because it doesn't actually have the mapping and a router does, that the router will send back some sort of redirect and we can eliminate the triangular routing. The identifier, as I mentioned, we take out 4 bits, so that leaves 60 bits. The basic properties are uniqueness, obviously, within a domain. We also want it to be non-predictable, so that if somebody knows one identifier that's generated, they should not be able to easily predict another valid identifier or the next one allocated or something like that. And it's very likely, in order to facilitate this, that in a network we want to have a decentralized identifier creation scheme. So there is some work on this. RC 4122 gives a nice plan to use timestamps, host identifiers, and things like that. So we do believe that with a reasonable structure, using all 60 bits and a timestamp base, we can have pretty much every actual physical host in the network be a registry or creator of identifiers. And using timestamp, considering they may be allocating 100 per second, that gives us about 22 years worth of identifiers before rollover.
Maybe can I jump in with a question on why non-predictable? Because in a data center, it wouldn't seem like there's security issues. So is that? This actually came up this week. We added it based on the discussion about MAC addresses and IPv6. And I think the fundamental, the spirit of that was that we don't want addresses to be easily traceable back to host. And the other assumption here is that if we did apply this to something like mobility, this may not be overly specific in the data center. And in fact, there's no reason to believe that identifiers, we couldn't export those to the internet anyway. The internet doesn't know ILA, but it will still know the SIR address, which is externally routable. I kind of have some pictures on that, but it just seems like the conservative approach. Okay, thanks. Hopefully it's not overbearing in the algorithm. So the ILA routers, as I mentioned, these will be populated in the network, and they will provide a translation service when a host is either not ILA capable or doesn't have the mapping. They basically respond to the SIR address. So the SIR addresses are routable in the network in the sense that they are anycast addresses that will hit an ILA router. The ILA routers map identifiers to locators. They participate in a control plane. One of the assumptions is that the ILA routers have access to the full mapping table that hosts may not, and that's probably where we get into talking about NBAs and the distribution of that. And as I mentioned, redirects would be the way to inform ILA-capable hosts that you have a better path. So it's kind of like the IP redirect, same mentality. Here's an example of a communications flow. We have a source talking to a destination, and the application in this case is sending to 333 or quadruple 3, I guess, 1, which is the address it gets out of DNS. That's basically a virtual address, and the destination is the
where that address currently resides. So in the beginning, we'll assume the host does not have this mapping. So we'll send out a packet with destination address 33331, and that will go into the network, be anycast routed to the ILA router, which is at the top. ILA router does the mapping, so it will look up the destination address. It will find that quadruple 31, the destination locator part, maps to physical locator 22221, colon 1, whatever. So that's the actual locator address. So the ILA router overwrites the top 64 bits in the destination with this new physical locator, sends that into the network, and that will be routed to the actual host where the identifier currently resides. So that's how we facilitate communication. In the meantime, the ILA router can send back a redirect to the source saying, oh, by the way, here's the direct route for that particular identifier. You can go straight to the destination. And then subsequently, the source that's ILA capable can just send directly to the destination, and the ILA router is out of the picture at that point. So one of the things you might have noticed is that we are modifying the destination address in a form of address translation. In multicast, presumably, we may need to modify the source address too, although we haven't fleshed that out completely. But in the case of modifying the addresses, this will affect any transport layer checksum that includes the pseudo header. So what we did in this case is kind of borrow the concept of checksum neutral translation from some of the IPv6 network RC 6296. And we had to find a place in the packet where we could put the adjustment value. So what we did was take the low order 16 bits of the identifier, and we'll use that as the adjustment value in the checksum neutral translation. So on transmit, once we decide the locator that we're overwriting in the top 64 bits, we compute the ones complement difference between the old locator and new locator. That becomes the adjustment value, so we add that into the low order 16 bits of the identifier, set the C bit to 1, which indicates that we've done this translation, send the packet to the receiver, and the receiver does the reverse translation, and at the end should wind up with the exact same IPv6 address that the transmitter started with, including the identifier being the original identifier, and back to the SIR address. So there is a control plane here. And as I mentioned, it's similar to NVO3. Its job is to disseminate the mappings amongst ILA routers. Our initial deployment, we're intending on using BGP. So Peter actually talked about this a little bit the other day. We do believe that scaling to the 100 billion object model probably will require a little bit more thought. There actually is another control plane model from NVO3 that we'll probably be revisiting soon. So a little on BGP, why it's a good control plane. We like to use existing protocols. We've already have BGP pretty well deployed. It's known to scale to a few million prefixes. It's easy to extend, simple changes. We've already defined a BGP AFI for ILA, which has both locators and identifiers. So protocol-wise, it seems like it's pretty extensible, and we can build a control plane around that, at least for the first pass. So I wanted to give a little bit of comparison of ILNP. As I mentioned, most of the concepts here really are borrowed from ILNP. Some of the differences, though, is ILA is IPv6 only. Obviously, if we want to route to billions of objects, IPv4 is right out. So IPv6 is kind of the requirement to use ILA. ILA is transparent to the transport layer, and this is actually very important, especially in real-world implementation. ILNP requires changes to every transport protocol implementation, as far as I can tell. ILNP, completely layer 3. As I said, it's just network address translation. And in order to facilitate the checksum, we don't even bother to look inside the packet. We just do the checksum neutral. So everything happens really on the in the IPv6 addresses. We don't even right now need anything else in the IP header. One other difference is that we did define some messages based on UDP or ICMP. I guess this is probably something that we could discuss a little more, which is better. But the redirect messages, we kind of like that if they're simple and not complex. So I still think of this as more like an ARP. So I'm not sure we need a lot of policy information or other guidance in redirects. Some other comparisons. So the control plane, we really are kind of not defining a control plane for ILA. The belief is that it's separate. We can leverage other work, definitely NBO3. If we can borrow things from ILNP and they do some things with DNS that might be interesting, we will. But I do believe that a nice separation between data plane and control plane probably serves us well, especially in the early stages of deployment, when we need both avenues to go different directions, or at least their own direction, in order to become viable. The other thing is that, as I mentioned, ILA definitely can work at the end host or in the network, and this is based on the SIR addresses, the untranslated ILA addresses being anycast and routable in the network to an ILA router. And this also entails no real requirements on DNS, neighbor discovery, pretty much security, anything above IP should kind of be compatible with ILA, since we're doing the translations before any processing is done, before anything above IP. So we did consider some alternatives in IPv6, and this actually came up in Yokohama. One of the earlier ones, I think Fred Baker was mentioning this for a while, was to use a flow label for virtual networking identifier. So this is kind of like looking for something in the IPv6 header that may give us extra information to do, say, virtual network isolation. So there were some issues with this. It wouldn't be clear to a host that receives a packet and the flow label is set that it's a virtual networking identifier, especially if they don't participate. So they would just see the IPv6 addresses as addresses and try to deal with them without virtualization. It's only 20 bits of information, so obviously kind of limited, not covered by transport checksum. The other, probably more interesting possibility was to use extension headers. We kind of don't like this because one, extension headers still have this possibility of not really being supported in the network, performance-wise, or what have you. Personally, I'm really hoping that we do get to the point where they're commonplace and are quite usable. But technically speaking, the more interesting argument against extension headers really is what's happening in 2460 BIS right now. Currently, the proposal there is that intermediate devices cannot add extension headers inside the network, which would basically mean if we wanted to do an ILA router, the only way to do that would be to actually do encapsulation, which is exactly what we're trying to avoid because of all the overheads. So we can't just easily add, say, an ILA extension header, which would indicate a virtual network address. And the other thing is, again, it's not covered by transport checksum. So presumably, we'd also have to have something extra in the extension header to do some, at least rudimentary integrity checks. So the deployment, because we're out of time, so I'll go quickly. The deployment, IPv6 is needed. We are in the process of assigning /64 to every host. So basically, every host in our network will have a /64. This is being done for other reasons beyond ILA, but it really gives us the flexibility of allocating 2 to the 64th number of objects per host. So addressability with IPv6 really is great. Deploying the ILA routers, we actually have some work kind of to build this up. We believe that there's, at least first starting with a software solution, but this is probably something that we could also put into hardware at some point. And the other part of the deployment would be configuring SERP prefixes in the host. So the use case, or the use, basically hosts create the identifiers. There will be a registration process into the control plane. So the control plane needs to be aware of the identifier, be aware of where it is. If it changes, the control plane needs to be told. So it's kind of the interaction between job scheduler and control plane, or I guess object scheduler might be a more generic term. And then the control plane will inform the ILA routers. And once the routing infrastructure is set up, then yes, the host can start to send to the ILA addresses. So our status, we have the 4 IDs posted that I mentioned, probably some more development. I will be very interested to look at some of the IP mobility and the 5G work and see if there's some intersection there of functionality they might be able to leverage. We do have some code in Linux that basically it's a data path. It's actually fairly simple. So that's usable, and we've been doing a significant amount of canary testing with it. And right now we're kind of looking at how to deploy this, and as I mentioned, first step is assign/64, and then we're talking about how to do the task identifier, routers, development, things like that.
Michael Abrahamson.
That's Michael Abramson.
So I'm not going to write. Okay, someone else is going to write through my computer. So when you say it's integrated in the Linux 4.1, is that actually accepted by Linux, or it's you have a patch set against 4.1?
It was accepted.
Okay, so it's actually from now on it's in there.
Yes, and for those of you who want to get stuff into Linux at this level, my advice is keep it modular, simple. Don't change core stuff. This is a standalone module. It was pretty easy to get accepted. Actually.
Yeah, no, I think that's the more contained it is, the more it's likely it is to be accepted.
This is Linda Dunbar from Huawei. Thank you very much.
That is Linda Dunbar.
Yes. Yeah. Thank you very much for this presentation. I just want to let you know some relevant work which have been done in IETF before. About 4 years ago, we had a working group to look at address resolution for a large data center, and it's try to solve exact similar problem you have presented. And as a result of that, there was a RFC 7586. That's from Marvell. It was experimental mechanism. It's published as experimental. It's RFC on how to do this address resolution, hierarchical address resolution. I think you should look at it.
This was before ILMP.
Yeah.
ILMP was 2012.
This is 2015. So
2015.
yeah.
So was it ILMP based then?
Actually, I kind of forgot the detail, but
okay.
You can look at it. And also in Trail working group, even though Trail is different than what you're having, but the control plane there, they have a smart end node, be able to do some hierarchical address. That's actually a similar solution can solve your problem as well. Thank you.
I imagine Trail has a similar problem. One of the things we encounter is that the identifiers are not aggregable. And this is a problem in virtualization, right? So in theory, I could have my virtual addresses all over the planet, and what you effectively wind up with is nothing but host routes. So that's going to be kind of tricky to scale to the hundreds of billions. It's one of our challenges.
Thank you.
This is Dino.
Dino
Farinacci. Thank you. Great pronunciation. I assume you're not translating the source address. Is that true in the packet?
Can you repeat that?
I'll stand back a little bit. I assume you're not translating the source address in the packet. Is that true?
Yes.
Okay, so when a trace route is returned, it'll be returned to the SIR prefix, so it'll have to go through an ILA router to get translated to make it all the way back to the original source?
So that brings up a very good question. I think that's more a question about ICMP.
ICMPs in general, yeah.
Where the translation occurs.
Did you not translate the source because you didn't think you needed it, or it just wasn't important, or you didn't know what to translate it to?
So the ICMP message will be performed on the basis of the addresses as they are. So obviously some node in the middle of the network that sends an ICMP error is just going to flip the addresses and send it back to the destination. And then the ICMP data obviously includes the untranslated thing. When that does get back to the host that presumably sent the packet, I think there's several possibilities. So traceroute's interesting because we want to know the actual path. Whether or not we need to translate back to the server address is an interesting question. But clearly, if we need to get back to some layer 4 context, say we need an ICMP error on a TCP connection, then we are going to have to do the translation within the ICMP data. So from that point of view, that is something we do need to handle. And it's a little bit outside of just looking at the IPv4 header. So ICMP is a little bit of a pain.
So if the ICMP sender was also an ILA router or had access to the mapping, it could translate before it originates the ICMP, right? But
yeah, it's an interesting question. So
but I know you don't want to
ICMP
touch the center, right?
If ICMP it became part of the protocol, then yes. But we also want an element where we're sending through a network that doesn't necessarily support or even know about ILA anyway. Okay. So it's very transparent. Yeah. So I would assume all the messages, that's very good stuff. I think we probably need to flesh out ICMP in the ILA draft. And I imagine there's probably other things. Obviously ILMP would have that same issue. So more work to be done on that area, I think.
Michael Abramson.
Michael Abramson.
BCP38 considerations, anti-spoofing. If the network does anti-spoofing measures as it should, then I guess using this for mobility is a problem. Because the first node is resending to the second node when it's moved, and it keeps the source address of the packet, which was someone else.
Yes, as I understand it, one of the issues with ILNP is spoofing, and there does seem to be some value in tying identity locator.
We're way out of time, but it would be nice if this was brought up somewhere.
Oh, so we definitely will add some text to that. In the data center, I'm not too worried about this because we'll have stronger security anyway. Obviously, in the rest of the world, well, you can spoof addresses anyway.
In the 5G context, where you're going to have end devices that's going to have this, then you probably want to have BCP38 considerations in there.
The good news is I don't think there's anything particularly new here that hasn't been covered before, but yes, we'll have to address that.
So we will take one more small comment question from Dino Farinacci.
Okay. Just to let you know, if you need a control plane mapping database, the list mapping database is available as well. Because you said using BGP, but that's a push based. So.
Thank you.
So we find this work very interesting, and independently where it's going to be continued, either here or somewhere else, we welcome discussion routing working group mailing, please, and we will work with the ADs on final home for the discussions. Thank you very much, and see you in Berlin. Safe travel.